Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, Chad Gill here. I'm the host of the This is Concrete podcast, where I talk with leaders in facilities management, architecture, contracting, and more. This episode is brought to you by Concrete. Concrete is a concrete polishing and coatings company with nearly 20 years of experience working in commercial, industrial, and residential markets. So whether you need smooth transitions for warehouse traffic, a show-stopping lobby floor, or seamless concrete accent wall, we can provide the skill and imagination you need to make your concrete uncommon. So what are you waiting for? Visit us at thisisconcrete.com and learn more about Concrete today. We're also sponsored by Workforce Recon. That is a project tracking software that connects the office to the field crews. Their app, Field Recon, is built with a field-first mentality, developed by contractors for contractors, and includes time and asset tracking, messaging, and job documentation. So if you're tired of finding out days later what happened, check us out at workforcerecon.com and see your operations in real time. So joining me today is Dan Bigman. He's the president and CEO of Bigman Geophysical, a consulting firm that offers specialty training and support solutions to engineers, contractors, and government agencies that scan and test concrete infrastructure. He's also the founder of LearnGPR.com, where he provides ground-penetrating radar training for utility locating companies, environmental firms, engineering companies, and architectural and government agencies. He received his PhD from the University of Georgia and is an expert in non-destructive testing, remote sensing, and 3D modeling. He and his company have trained thousands of students across 4 separate continents, and his research on concrete testing has been published in scientific journals of international reputation such as Water, First Break, and case studies in construction materials. So yeah, Dan, thanks for coming on. I appreciate it. I think you may be the first PhD I've interviewed on this podcast. Maybe I'm moving up. Maybe I'm getting smarter. Probably.
Yeah, well, it's let me put it this way. I thought that PhD was something that you really had to be really smart for. Apparently, it's just like owning a business, which is if you work really hard, eventually 5 years, 6 years later, you end up with a document in your hand that says
6, 7, 8 years later, you may stumble upon one.
That's right. It's basically what happened to me, but it's amazing how just so much of that kind of like reapplies to business and in life, right? Where put your mind to something, stick it out long enough, keep doing it every day, sleepless nights and early mornings and all that. And I think what's nice about it is that people who are getting their graduate degrees in general, PhDs specifically, usually, right, get to go out work on something that's really of interest to them. I had some people who told me that, they'd complain, right, like throughout the process, like, oh man, I got all these books to read. And I was like, isn't that what you want to do? Like, you get to go sit down in a big comfy chair and go read a bunch of books and that's it. But yeah, it was interesting. It's actually what brought me down to Georgia originally.
Yeah, you got to love or hate them. They're kind of tearing up the conference there, but yeah, good time to be a Georgia fan, I guess.
Yeah.
Not too shabby. No, my daughter goes to Clemson, which is another school in that region. So yeah, she's pretty astute to that kind of thing.
Yeah.
So when you talk about infrastructure, concrete infrastructure, what are you referencing there?
Really the full gamut, right? We're talking both the building sector, and facilities management, but then all the way on the other extreme side, which is specialty concrete, which includes things like, concrete bridge decks and roadways, tunnels, could be hydroelectric dams or other dams, that are using concrete to construct that dam for water management, ecosystem management. So, it really runs the gamut. And people are using non-destructive testing on a daily basis. The most common way to use it is going to be in situations like a plumbing or electrical contractor needs to drill a hole right through a concrete slab in order to feed a conduit or pipe down. And they want to make sure that when they drill, they don't want to damage any of the embedded infrastructure, embedded objects, right? So post-tension cables are scary, right, to hit.
Yeah.
Conduit itself, it's scary to hit. And so, they'll find everything that's in there or do the best they can to find as much that's in there to reduce the likelihood of a damage of some structurally significant object, or reduce the probability of somebody getting hurt by hitting a conduit and getting electrocuted, right? So that's like the most typical application. But there's a lot of applications that are less, I don't want to say popular, but certainly less utilized, which are looking at larger scale infrastructure. Bridge decks is a really good example, or dams, and I've done quite a bit of work on dams. This stuff is deteriorating, right? If a dam has a problem, and let's say you're a big hydroelectric dam, and you're poured in the 1920s or 1930s, concrete wasn't super fantastic as far as the technology goes. Then the practices didn't have the same rigor tied to it that were required, and you're just exposed to the elements, right? Over the next 80, 90 years. If a dam collapses, it breaks, it's not just that the infrastructure is damaged, but all that water that's been held up behind that dam, is going to flood cities, it's going to flood towns, it's going to screw up the ecosystem. It could, wipe out electricity for hundreds of thousands of people potentially, right? And so inspecting these is really, really important to make sure we understand which dams might need to be shut down, which ones can refurbish, and which ones are fine and just need a maintenance program. And that happens far less, but the impacts of a failure could be catastrophic. Same thing with bridges, right? If a bridge is corroded on the inside because of construction practices and then exposure to the elements and poor maintenance over time, bridges collapsing while people are on it is just it's a really dangerous thing to handle. So that's kind of the range of concrete that's tested on a daily basis, but there's sort of popular, regular, everyday applications, and then some that are larger scale, more complicated, sometimes logistically difficult, that aren't approached as often as they should be. But the outsized problems when a failure happens on those specialty pieces of infrastructure happen, it's pretty outsized, right? The catastrophe is pretty large.
Yeah, I mean, the definition of downstream effects, I mean, for sure.
Yeah.
And but I mean, when you think about like inspecting these things, and I know you do ground penetrating radar, but as I'm thinking X-ray, that's fine. You're looking at a bone through skin and stuff, so it's something hard inside of small, soft, but concrete, pretty dense. I mean, how accurately can you see what's inside of it, and how are you seeing these things?
Yeah, it's a great question, actually. So different non-destructive testing tools are going to work on different physical properties of the infrastructure, right? So a GPR, for example, works on electromagnetic waves that penetrate, through the concrete. And then basically when that wave changes velocity or encounters some discontinuity in the concrete member, some of that energy is going to reflect back and get recorded by the GPR. So it kind of doesn't care, right, what it is in a way. There are some limitations to concrete. I can tell that in a second, but it just matters of it's traveling at a certain speed through concrete. It encounters a steel reinforcement. The physical properties are different between those. That wave's energy is going to reflect off of that steel reinforcement, get recorded back at the surface by the GPR, and then the technician's job, right, is to interpret that and say, oh, well, that's a steel rebar. On the flip side is if there's a delamination inside the concrete, right, like a parallel crack to the surface, but internal to the concrete, that should look different because steel and air are two very different materials as they compare to concrete, right? So basically, it's looking for those discontinuities. The big benefit of GPR is it has the potential to identify objects and defects of basically any material as long as it's different than concrete. The struggle with GPR is you don't always know what that response is, right? Is it a PT cable? Is it a conduit? Is it rebar? Is it mesh? It could be all sorts of things, right? Is it a defect? And so that's sort of its biggest drawback. Its biggest benefit is also its biggest drawback. So when it encounters steel, 100% of the energy reflects Okay, so you get this really nice response in the GPR, and sort of doesn't take a super duper expert to identify that there's something there. Flip side is if you use ultrasonics instead, right? Ultrasonics will go through steel, but it doesn't go through air, right? Where GPR will go through air, but doesn't go through steel. So you can use ultrasonics to try to find other defects that might be a struggle for GPR to find, because 100% of the energy of an ultrasonic wave will reflect off of an air pocket that's embedded in concrete. So basically, you're using like different tools right in your toolkit to try to identify all sorts of different information of importance for assessing the condition, of concrete.
So why won't ultrasonics go through air?
So because mechanical waves won't travel through air, right? So just the physical like ultrasonic wave can't propagate through that material. It like the physical properties of air don't allow an ultrasonic wave to travel through. That's why like if someone's wife's pregnant, or you're pregnant, a woman's pregnant, and they go to a doctor and they're going to do an ultrasound, right, to check out how healthy the baby is inside of the mother, right? They always have to put this like gel onto the mother, right? And so what happens is that gel couples the ultrasonic sensor to the body. So there's no air gap between the sensor and the body. So you can actually propagate that wave through the mother and, get reflections basically off of the baby that's inside. So then you have to use that gel. So because there's no propagation of ultrasonic waves through air, you have to use some special medium, right, to make sure that there's a coupling and that you're not having air. So that's why. And so basically mechanical waves, which is what ultrasonics is, compared to electromagnetic waves, which is what GPR is, they work on different, physical properties of the universe. And so you're allowed to sort of combine these different tools together to make, more comprehensive assessments of what's going on. Does that make sense?
It does. It makes total sense. And it's embarrassing. I have 4 children. I don't know how many ultrasounds I've been to. I thought it just made the sensor move around more easily. That's luckily since this podcast, maybe nobody will know.
Yeah.
That's awesome. No, it's really, so you kind of got to know what you're hunting to figure out what the right tool is for that.
Yeah, I mean, and again, the best programs are going to be multi-sensor. We recommend to our customers, our students, again, we do a lot of training. We recommend to our students that they always request from their client that they hire them and scope out multiple techniques. You're always going to capture more with multiple techniques. Doesn't mean the customer is always going to be amenable to doing that. It typically costs more money. But one thing we sort of try to recommend people do is, rather than say, we see folks falling into this trap, which is we're going to come out and do a GPR investigation of your, slab. Okay. That's sort of how they write the scope up, as opposed to, hey, we're going to do an assessment of your slab. And then they bring the tools that are, required and figure it out on site. Sometimes you have to educate the customer, because customer typically is going to say, hey, they're going to call the company or send an email through the website, right? We want a GPR investigation of the slab. They don't know what they want, right? Because they're not the GPR expert. They just, that's what they think they want. They've had people do GPR before. Their, colleagues have gotten GPR before, but it may not be the best tool. And those are just 2 tools, the ultrasonics and the GPR. There's quite a few more. But that's how we recommend folks go about it. And because there is such a lack of education around how these different tools work to the end user, which is the contractor or the facilities owner, that it's important for folks who are doing this type of work to educate, right? To educate their customer base that, look, there's a bunch of different tools, a bunch of different technologies. We're going to use, the right ones for this job. And so it's hard to sometimes tell what's going to be the best option on any given circumstance. It's going to depend on project conditions, limitations of the site. GPR, for example, if the concrete's recently poured, then GPR can struggle because moisture will destroy the GPR signal. And so if it's concrete that was poured 6 years ago and it's indoors and it hasn't been rained on, it's not been exposed to the elements and it's dried out, GPR, will be able to investigate further into that concrete. And so it just matters, what the conditions are like. And so, how do you figure it out? I think you try to bring all the tools you can. But number 2 is you ask a lot of questions, right, of the customers. Tell me more about the site. Tell me about the conditions. When was the concrete poured? What's the density of reinforcements in there? Is it really dense? Is it, is it not dense? Try to understand as much as you can. It's going to help people just be more successful, with non-destructive testing programs.
So we're a concrete grinding, polishing company and stuff like that. And we cut, we go in and we do, saw cuts and stuff like that. And, of course, we're always wanting to find out if there's a PT cable, because like I said, you'll only cut one of those. Mm-hmm. You'll remember it always. But it sounds like when you talk about non-destructive testing, if somebody says, hey, we're bringing them in, you feel like, okay, this is going to be super expensive. So is there, if it is, why is it so expensive? And if it's not, are there typical applications? We look for delamination of coatings. We look for, is crazing a bigger problem than or is it just something that's on the surface? I mean, where are the places where you would say, hey, this is the kind of thing that, yeah, you could do some testing that would answer these questions before you just immediately say, well, I think NDT is expensive, so we're just going to tear it out?
Yeah, I mean, so if I understand the question, right, is it expensive? If so, why is it expensive? And would there be reasons to just go ahead and forego doing the testing? It's a range, right? I mean, price-wise, I think it's a range in the industry. I think the people who know what they're doing typically are going to charge more. And I think, and so why is that the case? Equipment's expensive. Training can be expensive to do it right. I mean, if you think about an X-ray tech from in a healthcare situation, or like an actual radiologist, like that's a doctor, right? They go through 4 years of school, they do a residency and all that. Like, it's not inexpensive. And this is really the same thing. You're a doctor of, a radiologist of the concrete. You might not use X-ray, right? Although you could. We tend not to, for a couple limitations of it, but it does have quite a few benefits beyond its limits. But look, there's a lot of school involved with that. There's a lot of money to get somebody, to a radiology degree, and then a residency, and then all that. So if you want to do it right, then I think it costs money, right? You do have people who do just get some equipment and test themselves, and on really basic sites, they're probably going to be okay. But when it gets a little bit more complicated, that's when you're going to hit your PT cable. And like you say, you only hit one of those, but one might be one too many, right? So if you can avoid hitting that, then that's good. And if it does happen, because one thing I want to be really clear about is, like, there's no guarantees, right? It's all remotely sensed. So the only way to guarantee that there's nothing there is to excavate, right? Or drill, or, crack or chip out concrete. I mean, that's the only way to be 100% for sure. And so what we look at is the NDT is supposed to reduce the likelihood that you're going to have a damage. Okay. So, but if you hit one PT, that could be it, right? And so if you do hit that, but you've gone and done your due diligence, right, you're much better protected from a liability standpoint to say, hey, we brought in so-and-so, they're certified, right? They used GPR equipment, they used maybe ultrasonic equipment, or they used, an electromagnetic pipe and cable locator to verify that there were no conduits in it, so on and so forth. You go through the gamut of potential technologies, and they're still hit it, right? And so why is that the case? Well, fiber optic cables, for example, which typically are not embedded in concrete, shouldn't be embedded in concrete, aren't usually designed to be embedded in concrete. Sometimes corners get cut and people embedded them in concrete. Well, glass and concrete are very similar in physical properties as it relates to GPR. So it really has a tough time seeing fiberglass cables inside of concrete. And so you can't always guarantee, or you really should never guarantee, that the GPR, the ultrasonics, or any other tool that you use 100% identified everything. And so that's why it gets costly, right? So then we have to carry insurance and all that. So the people doing it right are the ones that tend to charge more. I always say to people, if you're going to underpay for it, then do one of two things. Either decide you're not going to do it and go in blind anyway, because it's not really going to matter, right? Number one. Number two is just siphon off that extra money you're saving now to pay to replace it later, and for the attorney and for all that, right? So you can do kind of one way or the other. But that's why I think it gets to be expensive. But I don't think it really is expensive, right? If it costs somebody, I don't know, $1,000 to bring a technician out to a site for a half a day, it's probably about in the range of what people charge. But it could save you, I don't know, millions of dollars, right? Or $20,000, $40,000. Yeah, whatever.
A PT cable, you could save some lives.
Yeah, absolutely. Then I think it's worth it. And you put that into the cost of having to do this business, and that goes out to the to whoever's the project owner, right? Not necessarily the contractor. And I think that, I mean, think about what's a delay cost, right? Forget even the damage, right? If you have something happen and all of a sudden your project's delayed by 2 weeks, right? That's a hefty bill. And so, I think that it's pretty inexpensive to come out and have somebody do it right over time and have that peace of mind, right? Because you're not really thinking about it at that point. And so that's kind of my feeling on it. Is what people spin is it's expensive. It's expensive compared to what, right? It's expensive compared to zero, but it's very inexpensive compared to a damage. And if we save you one damage over the next 5 years because we're coming in every week to test a site, then you've done really well. You've amortized that problem over 5 years. It's really cost you very, very little, right, on a case-by-case basis. But it's giving you that peace of mind and help reduce the likelihood that you're going to have a damage. It improves site safety, reduces liability, probably can make a case that it reduces insurance costs. And so, that's it. We're actually encouraging contractors now to say, hey, even if you pull in a specialty, scanning team, you may want to add a tool to your toolkit, because if they scan an area that's 4 foot by 4 foot and you decide, well, we're going to put a drill right through this spot right here, right? It doesn't hurt you to go back in right before the drill touches concrete and just scan it this way, this diagonal, yep, we don't see anything here either, and then drill. And so I think it's worth it to have, somebody on site be trained in the technology to be able to use it really superficially, but as that final layer before before drilling occurs. So
yeah, you kind of triaging it a little bit. It's like, hey, this tells me whether I need to get the expert or because so when you're thinking about places where you're using this, when you're saying, well, it's obviously, okay, we're gonna install a manhole, or we missed a hole, we got to drill a 24-inch hole. That makes sense. I need to get that checked. We're gonna put a new door in a structural wall. We got to figure out what we're gonna hit and stuff. What are the more unique situations where either people aren't using it and should, or are using it and it's just not what we think of?
I think that unfortunately it's not unique, although it's become more and more unique over time. But there's plenty of contractors out there who are not calling in people to scan before cutting, coring, drilling, and all that. And I think you hit on a really important point, which is triage. If you roll we can teach anybody how to roll a GPR over the ground and find what a rebar looks like. Really basic stuff. So if you have like a single rebar mat and it's a 12-inch, on center, kind of 12-inch by 12-inch grid, somebody can come in who's worked for the contractor and test that quickly, right? And define, okay, well, is that all that's appears to be in there? Yes, great, boom, right here's fine, drill. Versus, okay, we've got two levels, we have a what appears to be mesh, which we don't really care if we hit, some contractors don't. But if it's not mesh and it is really structural steel, that could be an issue. But then we have a second layer. We also have this odd response that's not in line with the grids of the reinforcement. That could be something. There's a whole lot going on here, and I'm struggling to figure out what's going what direction. Then you can call in a specialty contractor to say, well, we need to hire you because this is more complex. But there are people out there still that are not scanning beforehand. They say, hey, drill, if we hit it, we'll fix it, and for what it's going to cost us to bring somebody in over and over again, we'll probably be okay and typically not hit something of importance. And if we do, then we'll pay that out. But we're going to have to pay somebody to scan anyway. Problem is, like I said, you could have 5 years worth of scanning cost $200,000 over 5 years or something like that. But one damage, one time can cost you well more than that. So I think it's those kinds of situations where people there's not enough scanners in the area, right? So maybe take Atlanta, for example, where I'm from, where there's more and more, but they might have a situation where they call somebody, they're on site. They call somebody else, they're on site. They go to the third name on their list. Hello? Yep, we can be there in 2 days. Well, we kind of need it done now because we don't want to wait 2 days because every day costs us money. This is our project schedule. Forget it. Just drill. So that's when people, I think, are also not bringing out the concrete scanning and testing contractors to do it. Is they might be amenable to having that happen beforehand, but if their schedule doesn't allow for it, then they're just going forward. but you can ameliorate that if you take somebody who's local to the company, get them trained. You might not need somebody coming in for 2 days anyway, because it might be basic, and just find where that stuff is. And so I think more and more it's becoming the norm. And too many people have been burned, after hitting something. I think what happens sometimes too is you get someone who hires a contractor. They say they're an expert or a specialist. They come in, they do a shoddy job. You hit something anyway. You say the technology doesn't work. We're not going to hire somebody. We're just as good to drill here as to get somebody in because we hit something anyway. Problem is, they may not have been trained. I have no idea what kind of equipment they use. I don't know what their practices were. I don't know what the sources of noise in the area are, and how that impacted the quality of the data that they collected. And those people probably didn't know either, right? So what happens is there's all these other factors, but they tie that to the technology, as opposed to every technology was fine. Everything else was the problem. And, you should have done better due diligence on a contractor.
So what's the difference in, it's interesting, so non-destructive testing versus remote sensing? What's the difference in that?
Yeah, I mean, they both, I mean, technically can argue are the same thing. I mean, sensing is often considered really identifying things that are below surface, or something that's not it's not destructive. Testing kind of comes a little bit more, in my view of things, as sort of condition assessment, right? So testing is a little bit more like assessment. Sensing is more like identifying and embedded objects. We sort of look at non-destructive testing and remote sensing as sort of, non-destructive testing is more typical for concrete, where when we talk remote sensing, we're talking a little bit more of like earth-based applications, like geophysics, right? So for example, you might be finding where sinkholes are. I mean, I'm going to go down this road, but it actually totally relates to concrete, right? But something like that. So we kind of look at it that way. It can get convoluted, as far as the details or the semantics of different terminology. Both fall under non-destructive, right? Where you could be testing the condition of concrete. You can be searching for sinkholes or subsurface voids or things like that. Could be locating utilities and mapping them. You can be we work on forensics and heritage projects as well, where we support them. So finding unmarked or clandestine burials for various reasons, or mapping archaeological sites. For collaborators at universities. But that's how we kind of internally in our company distinguish it. Let people argue with me about, well, non-destructive testing really should be non-destructive evaluation. This now is like, I don't really care. We're going to go help somebody make sure they don't hit something, and that's, to me, the most important thing with that, but prior to any sort of destruction.
I mean, can you do substrate testing? Like, we'll do a proof roll before we're going to pour concrete or something like that. But is there a way, like, you could get density on, we interviewed a guy the other day, and they do, the ground support because they have bad soil in there. So they're mixing cement with the ground to get to increase the density. That the kind of thing, like if you're like, hey, I'm getting ready to build here, do I have good soil and that kind of thing?
Yeah, I think that it's a very good application, right? So for example, the technologies are going to be limited in the detail they can give you about the soil specifically. There'll be maybe some indications about density and things like that, but what we could do is let's say that you need to put in the supports, and you're probably going to drive those things down to bedrock. Well, how deep is bedrock, right? How big is that support going to have to be? And so prior to you drilling to get to bedrock, we can potentially tell you how deep that bedrock is, what the topography of the buried bedrock is, maybe then what are the best places to anchor it in, right? Maybe where it's, and I don't know how to anchor stuff, but maybe where it's flattest or where there's not an angle or, whatever. So that's the kind of stuff we can do beforehand. Or, again, identify potentially voids that have developed. So let's say that there's a water pipe that's coming through the site, it's broken, and it's been spraying water at the bottom of it, and now you're eroding away soil, and that can be a structural problem, to build on top of. Those are the kinds of things that we can identify as well. So that's stuff that absolutely can happen prior to a concrete pour, where you're looking at depth of bedrock, identifying, potential hazards before pouring, or even identifying where, existing infrastructure is underneath the ground, such as utilities and pipes. culverts, drainage systems, and things like that.
Yeah, I mean, it just, there's just a lot of places I think where, we probably just don't think about it. So you learn GPR.com. That's there to provide training for these kind of things. And then this equipment can be rented if you wanted to do like an initial triage type of thing to stick with our work.
Yeah, I mean, learngpr.com is a digital, platform that we have. There's a lot of free content on there for people. And then there's, some paid courses and stuff like that. But we also offer hands-on workshops. It's one of the more popular things that we do. And so either people come to people can come to public workshops that we hold on like a regular basis, or we can come in and train their whole team. Our team is like agnostic when it comes to technology. So I don't care if the box that you're holding in your hand is, orange, red, yellow, blue, black. We want to make sure that whatever you have is what is the most appropriate tool, that you're able to use it in the most appropriate way and that you have an understanding of the functionality. Then we also rent equipment. We'll get people who, GPR, for example. So let's say you have somebody who's testing concrete and they have a high frequency antenna. It's going to be high resolution, but it's going to go shallow. And they're typically testing concrete that's 2 feet thick or less. But they come across a project where somebody wants a mat slab investigated, and it happens to be 4 feet thick. They may not have a tool that will go 4 feet. So we have a fleet of technology that we're able to rent out to our customer base to say, hey, it's a unique one-off for you. Go buy a whole piece of equipment. Number one, don't refer this out. I mean, hold on to your customer, but just, we'll get a piece of equipment in your hand that can go 4 feet deep. And then if you're unsure about the questions that they're asking, we have a team on the back end that'll actually do the full evaluation of your data. And so basically we're doing everything but collecting the data on site. And then we'll help them satisfy the customer scope, satisfy the customer that they were able to continue to do the work for them. So that's how we basically go through and support folks over time. It doesn't have to be super duper unique, but we have a fleet of specialty equipment beyond like the daily, scanning equipment are. Ultrasonics, for example. A lot of people don't get ultrasonics. I mean, structural engineers will typically have it, but even many of them don't have it, but they're soliciting projects that might need it. And is there honeycombing inside the concrete from pore sifting? Is there delamination? Things like that. Ultrasonics is often a better tool than GPR, but they may only get those calls a couple of times a year. So we'll have that specialty equipment that they can rely on, when those projects come up. So that's how we support them. I mean, again, the training is a big part of what we do. I'm a huge believer in education. I come from academia. So when I came, and I had to have kind of an evolution myself too, came from academia, taught the first workshop that I taught. And it was a little much, I'm gonna be honest with you, and we had people who were on the side of the road and on their hands and knees. And I had to reduce the math that was in the course for people, which was good. I mean, we all have to reflect and learn and get better. And so it's come a long way, right? Super duper practical, but also continues to talk about theory concepts with, a little bit of math. And it's been a really big help for people. I mean, we recently did a survey of our customers, our students, and something like over 90% said that they were more efficient, after being on a project site, with like 45% saying that their efficiency went up by 50%. And it's because if you don't understand how the technology works, right? And we're not telling people, hey, run through the site. We don't think that's the right way to do. We want you to be effective, but you move so much faster and more accurately, right? And you actually prep your customers and set expectations that are real when you understand how the technology works and you have a recipe for how you're going to apply the technology on site, right? Fortunately, people who even are doing it for a while who haven't been formally trained, still every site's like a whole new process, and that's a problem. And so people just become inefficient, and so we're getting these really good marks because education is so critical, right? It's like we can't even help you with the back end of everything until you're educated as a professional. And so I always encourage people, become more professional. Excuse me. People watch videos, listen to podcasts, and all this stuff. Yet when we tell them, hey, why don't you come and do a 2-day workshop? It's like, whoa, that's really intensive. And I'm like, if you want to make kind of a career, 2 days isn't really that intensive, right?
Not that bad.
Yeah, it's not that bad. And look, and what we do is like take the 15 years that I've put into this, right? And the school that I had and and paid for and all that stuff, right? All the hard work I did for that PhD, right? And pushed through. And let me condense that and put that into a really consumable format that's going to help you be better off the back end. In that same survey we did, like something like 96% said they were more accurate after the course. It's just it's so not everybody was, but it was a pretty high number, right? And so I just think that when you get education, it's so helpful. That being said, is you have to pair that with real world experience. And when people come through our like intense classes, at the end of it, I'm like, welcome to being a beginner, right? You were a zero before you walked in.
Right.
Basically, right? And now you're a beginner, but now you can take all this stuff and apply it to your sites, and you're going to see that that trial and error is a really slow way to learn. So having fundamental knowledge and then going and still having successes and failures on site, because people will still fail, right? But understanding why your learning rate, right, from your experience then has this like huge curve up, right? It becomes really exponential, where trial and error without foundational knowledge is like trucks along and you kind of get a little bit, and then 17 years later, you're better than when you were when you started. But we have people who come to our trainings who say, man, I wish I had this 17 years ago, because like there's stuff that I knew and I didn't know why, or there's projects that I did that I would have done differently. And so education is a really important piece. And so we want to make sure that everyone has access. So that's why we have Learn GPR, which is available to everybody. Doesn't matter where you're in the world, free stuff, low cost stuff, more intensive stuff. And then we try to help, once people go through education, we try to help and support them in ways that we can, making sure their equipment is accurate, reliable, can create repeatable measurements, that they have somebody who's willing to process their data and analyze it for them if they're in a bind or they don't have the manpower, or it's beyond their comfort level. And and so we support them on their projects as well. And so that's kind of the way that we work. Basically I built the company to be a contract firm. I came out of teaching. I went to school after going to school. I taught for 2 years at university. And then when that contract was up, I decided to go into the private sector. I was knocking on doors saying, hey, I have equipment. Let me go do the work for you. And a lot of people said yes, but a lot of people said, hey, we have the same equipment you have and nobody knows how to use it. So will you teach us how to use it? And I said, sure. And so we did that. And then we started to realize, well, people kept asking us for additional help. And we just tried to make, sure that we developed like innovative solutions that allowed us to help them. And that became the big thing, is I just want to help people, right? We want to make sure that they could, because what we do, it has real impact in people's lives. Like communities are safer, I think, because the people out there on their hands and knees are doing the work that they do, right? Kids in their playgrounds are safer because gas lines and electrical lines aren't getting, damaged, or gas line could be an explosion, right? People in buildings, right, working on job sites, working at hospitals are safer because when they're doing a reconfiguration of a part of the hospital, that post-tension cables aren't getting damaged, right? We try to do assessments, so if buildings are getting deteriorated, right, because of corrosion or other factors, that they can mitigate that early, right? So the stuff we do, I think, is real impact in people's lives, and it keeps people safe, and it keeps people working, and it keeps people productive. And we want to make sure that the people who are actually out in the field doing that work are trained, or have at least availability for training, and have a support system. Before we came along, it's just like I was stunned that there was so little education available and so little folks out there trying to just help the actual technicians and professionals out there that are conducting the scans.
Man, that's fantastic. And I think just as easy as, it's just as important to find an errors. I'm assuming you can use this technology to then validate the repairs so that you know you got a problem solved.
Yeah, I've recently published a paper, an article on it. It's free. It was in the journal. It's called Water is the name of the journal, if anyone's listening. And it basically was us using a crawler, like an unmanned crawler with a GPR attached to it. We dropped it into this huge concrete hydroelectric dam to validate the repairs that were done after we did an initial scan, right? So we went in there, covered 60,000 square feet. We partnered, it was basically a research project. We partnered with this group that was doing the resurfacing. And they were basically looking for delamination, chipping out the bad concrete, putting in reinforcement, and then resurfacing. And so we did all that manually, right? They built the big scaffolding, and we had to go down there, and it was steep, man. I tried to stay up and try to make sure that I was kind of slanted myself this way so I didn't fall down the edge into the water. But we had to do all that manually. So we covered this big area, identified a bunch of problem areas. Some really didn't have problems, and some did have problems. They chipped out that stuff, and then we said, man, we really don't want to build another scaffolding, drop back down there, go test all this stuff. So we did a kind of a second leg of this research project, is where we put this GPR little handheld one onto a crawler. The crawler had a vacuum seal on it, and so basically we dropped it in, and it sucked to the side of the dam, and we tested if it could verify how many reinforcements were in the in the repair, what was the distance between reinforcements, how consistent were the depth of the reinforcements, how thick was the pour of concrete, and all that. And so it's so point is, I wrote it up so people can see it, and it's absolutely something that's not used enough, right? As opposed to, well, did you really do the work you were scoped and contracted to do when you had to repair? Almost nobody goes back for that. And so this almost falls within like forensics, right? Where you're testing and validating what somebody did as being true to the scope. And it's not done enough, and it should be. The only time it's done is when somebody has a problem.
Yeah. And at that point, it's too late.
And you could prevent it, or make sure that somebody's listening to what you're doing, and that they're not cutting corners. But I've been a number of projects like that where our team has supported folks who had issues, as whether or not the build was in line with what the design was, and it's pretty quick to, in some of these cases, to validate whether or not it was or it wasn't.
Man, Dan, then I don't know that there's a short course on GPR, but it sounds like it's at learngpr.com.
Sure.
This is helpful, man. This is it's really good because we see concrete from the surface and maybe a little bit deeper, not very far. But I definitely understand the penalties associated with some of the things, particularly, like we talked about cutting a PT cable or hitting a high voltage line inside of it. So this is great. And it sounds like this is a place that could use some more people in the field. So yeah, I know as people are looking around for different opportunities, it sounds like this is a really good opportunity as an add-on to a company that's already working in that arena.
Yeah, no, I agree. It's important. It's important work that these folks are doing out there, and and I appreciate like all these folks on site every day, making sure that things aren't falling down.
Yeah, it's just better when they stay up.
I agree.
Exactly.
Yeah.
Well, I really appreciate you taking the time out to join us and kind of giving us a run through on it, and look forward to learning more about it. Like I said, you guys can see it at learngpr.com, and his company is Bigman Geophysical.
Yep. And then our website for the company, the main company, is bigmangeo.com.
Bigmangeo.com. All right. Thanks a lot. I appreciate it, Dan.
Thank you. Appreciate you having me on.
Have a good one.
You too.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.